viewers all over the world. I'm Sir Lumaj. Today we are continuing from where we stopped in the last class. Today I'll be talking about organic chemistry. And under the organic chemistry, I'll be talking about alkyne. In our last lecture, I spoke about alkenes. So here also I want to talk about alkynes. Alkynes, just the way I explained alkenes, they have the general molecular formula of CnH2n minus 2. Don't forget alkane, they have CnH2n plus 2. Alkyl, CnH2n plus 1. Alkene, CnH2n. No, this is now alkyne. So alkyne is what? CnH2n minus 2, where your n is equal, greater than or equal to 2. That's the way we did it for alkane. And don't forget, I told us that alkene and alkynes, they are unsaturated aliphatic hydrocarbon. You know when I say, your alkane, we have in alkane to be this format, where we have this single bond. I call it sigma bond. It's a covalent bond. So what happened there is that, I told you have hydrogen for your, this an example of what do you call it? This is met A. So what happened in your your alkane is that we have two hydrogens removed. The basic the very good example we could use your ethene, where we have your C2H6, where you have this. So your alkane, so your ethane, which is a typical example of alkane, is going to lose two hydrogen. So that reaction is called dehydrogenation reaction. I told us in the last video that there will be a video I'm going to do where I'll be talking about reactions. So here we have dehydrogenation reaction, whereby two hydrogens hydrogen atoms are knocked off from this compound. So when you remove these two hydrogens, you will now use it to form a double bond. Carbon to carbon, double bond. Carbon to carbon, double bond. So this is your sigma bond. Then by the time you remove these two, it will now form this pi bond, which is a weak bond. It's a weak bond. The same thing applies that when you remove another two hydrogen atom from here, it will form another bond. You now have carbon to carbon triple bond. So for alkene, we have carbon to carbon double bond. For alkene, we have carbon alkenes. For alkenes, we have carbon to carbon double bond. I believe you all understood how we got carbon to carbon double bond now. So for alkyne, I told you two hydrogen atoms will also be knocked off. We now have carbon alkynes. Now we now have carbon to carbon triple bonds, where this one, or let me call the center one, is now the sigma bond. This is what? The pi bond. This is another pi bond. They are covalent bonds. So what happened is that the law of tetravalency has to be obeyed. So for this carbon, we have 1, 2, 3, 4. For this carbon atom, we have 1, 2, 3, 4. So by the time I start talking about reactions, then I can now be telling you how these bonds can now be broken. Those of you in 100 level chemistry in the university, that's when they're talking about Markovnikov's rule, where you'll be having carbanion, carbocation. So later we'll talk about that. So we have this carbon to carbon triple bond. That is for alkynes. So just the way I've done for alkenes. serial number. We have the chemical name. We have the molecular formula, MF. We have the structural formula. So when N is greater than or equal to 2, you put 2 in this. We have C2, H2 into bracket 2 minus 2. We have C2, 2 times 2, 4 minus 2. So this will give us C2H2. So there is no magic in this, no single magic. So for our first compound now, it will now be what? Ethyne. Ethyne. From here, hyne. So it's ethyne. So the molecular formula now, don't forget, this is what we have. C2H2. The structural formula now, don't forget, the first thing, how many carbons do you have here? 2 carbon atoms. So it's now what? Carbon to carbon triple bonds. Law of tetravalency for this carbon. 1, 2, 3, 4. For this carbon, 1, 2, 3, 4. Then by the time you fill in, you have this, you have this. Without even looking at the thing we got here, the C2H2. What do you have? You have this as the what? The structural formula of what they call it? Of ethyne. If you now look at this is linear. The structure is what? Linear. So you say alkynes, they have a linear structure, a straight structure. For alkenes, they have what? A planar structure. For alkanes, they have the tetrahedral structure. I'm trying to describe the way they look. But if you look at this one is straight. That one is planar. If you remember the way I did my alkane, this is planar. And your alkane is tetrahedral. So there is no magic. Just follow the principle. It's very simple. So this is tetrahedral. Alkanes are tetrahedral. Alkanes are planar. While your alkynes are what? Are straight or linear. Straight or linear. So that's the structure of ethyne. Let's go to the next one on the list, which is what? Propyne. Propyne is 3. So from this we have C3, H2 into bracket 3 minus 2. We now have C3, 2 times 3. That is what? 6. 6 minus 2. That is what? 4. So we have C3H4. C3H4 is now the what? The molecular formula of propyne. And don't forget, I said homologous series differs by CH2. No, by the time you add CH2 to this is C2H2, C2H2 plus CH2, CH2. What do you have? You have C3H4, which is your what? Your propyne. If I do the same thing to this, C3H4, homologous series divided by CH2. The next one will be what? This is C4H6. Then your butyne will be C4H6. Your pentyne will be what? C5H8. So writing the structural formula of this. Of propyne now. You first have carbon to carbon triple bond. Carbon to carbon triple bond. So in carbon to carbon triple bond, we have 1, 2, 3, 4. 1, 2, 3, 4. So how many carbon do you have? We have 3 carbon atoms. This is 1, 2. Is that you add to the front or you add to the back? These are carbon. So here we have completed the 3 carbon atoms. Then your hydrogen. This is 1 to this carbon, 2, 3, 4. 1, 1, 2, this is complete now. Look at this calculator. 1, 2, 3, 4. So you are not adding anything again. The bonds are already completed. So you come to this one also. 1, 2, 3, 4. You had hydrogen. That is for what? Your propyne. So I will leave you to do butane, to do pentane on your own. So if there is any problem with that one, you can let me know in the comment section. Don't forget to subscribe. Don't forget to like it. I tell you, this is just the beginning. We are going to enjoy chemistry for real with Sir Lumaj.